In this tutorial, we're going to go over how to create a drawing of the Titan 87L in Fusion 360. Let's first take a look at the Titans of CNC drawing, as we are going to be using this as a reference to create our drawing. In our upper left-hand corner, we have our front view. And as you can see, we have some section lines splitting our front view in half and dropping it down here as our bottom section view. Going to the right of our front view, we have our right view. And as you can see up here, we have a small detailed view, which can be seen here. Underneath our detailed view, we have an isometric view, further clarifying some of the features on our part. So let's jump into Fusion 360 and create this drawing. I'm in Fusion 360 right now. And one thing that we're going to do is we're going to have to do a couple steps to get this part set up to create a drawing for. The very first thing is if we look at our view cube up here, it currently says that this orientation of our part is the front of our part. However, on our drawing that we just referenced off of, it says that this particular view right here is the front of our part. To change this, what we're going to do is orbit your part over, and then once you get it kind of close, you're going to click on the words here that are stated in your view cube, and that will kind of orient your part square into its workspace. Then you're going to right click on the view cube, go down to set current view as your front. Now, a couple ways that we can create a drawing for a part that has threads in it. Currently my threads are modeled in here, and you can see this by moving your mouse around. You can actually see all the helical features. The issue is when you have modeled threads, sometimes it doesn't show up very well in our drawings. This particular one, we're going to edit this to go to unmodeled threads. We're going to go down to our history markers down here and right click on our whole features and uncheck modeled, and then press enter on the keyboard. We're going to repeat that for the other whole feature, turning those modeled threads off. Now if you look at your threads in here, it's actually an image of threads. It's no longer a helical feature. And we're ready to go over to our drawing workspace. First though, we need to save our part. And then we're ready to change our workspace up to our toolbar and down to drawing from design. In our pop-up window here, it's asking, do you want everything in your modeling workspace to be a part of your drawing? We do. We are going to be creating a new drawing off this part. And lastly, we are going to be referencing our Cougar Manufacturing title block, which can be seen in another video. And then press OK. The very first thing that Fusion 360 is trying to do is land our front view. We're going to come over and we're going to turn on tangent edges. And we're going to set this part in the upper left-hand corner, like so, and press OK. One thing I want you to look at is, notice we've got a lot of these invisible lines, these hidden lines here. So we're going to double left click on this and go from visible with hidden edges to just visible edges and close that out. Now that we have our front view, we're going to add in our section view. So into our toolbar, clicking on drawing views and going down to section view. We're going to gesture our mouse over and click on top of our front view. And we're going to gesture our mouse to the center here and extend away from the center. And you should see this green dashed line here. We're going to left click there and then left click again on the other side of the part and press enter. And that will lock in your section lines. Dragging our mouse down, this will create our bottom view. Left click on at that location and press OK. Notice now if we look in our section view, we don't actually see an image of threads. What we do see is these dashed lines here that actually make up our thread geometry. And that's okay. Our next view that we're going to land is our right view. Back to drawing views, down to projected view this time. We're going to reference off of our front view, this time dragging our mouse to the right, and then right again and at the bottom, and that will land in a projected view, or excuse me, an isometric view. Afterwards, press Enter on the keyboard, and that will lock those views into location. Our isometric view, we're going to change this from a wireframe into a shaded with visible edges by double left clicking on it. And up here in our style, we're going to click on shaded with visible edges and close that out. Lastly, we need to add in our detailed view. We're going to go back to drawing views, this time to detailed view. We're going to zoom in here. We're going to click on our part, and then we're going to move our mouse kind of over in this area here. Left click and drag out this circle. That makes up our detailed view. If you make a mistake now, that's fine, because you can always alter your detailed view later. We're going to left click there and drag our mouse over to the right. We are going to change our scale of our detailed view to an 8:1 scale. And we're going to land this in our upper left hand or upper right hand corner. And then press OK. As I mentioned before, if you make a mistake on creating your detailed view here, you can always come back and click on your detailed view and drag these handles around here, and that will actually enlarge the circle that is used to create your detailed view. The center handle here, you can actually drag that around, and that will adjust the orientation of the detailed view, and everything will automatically update here in your view. Now that we have all of our views stated, now we're going to start adding in some of our dimensions. We're first going to take a look at our front view. And we're going to go D on the keyboard, which is the shortcut for dimensions. First dimension that we're going to reference is the outside of our part. We're going to click on it and drag our mouse up. The next dimension that we're going to reference is the inner portion of our circle. We're going to click on that and drag our mouse up. And lastly, we're going to reference this, this other circle here. Clicking on it and dragging our mouse up. Now be mindful, you can readjust your measurements after you land them by right-clicking and pressing OK. That will get us out of our dimension mode. And you can click on this handle here and drag these around to whatever locations you would like them to be at. Like so. One thing I want you to notice is the annotations of our measurements right now are only stated to the 10,000ths column. We're going to change this by going down to the bottom center, clicking on annotation settings, and checking the box where it says display trailing zeros, and then going over to linear dimension precision and down to the thousands column, 1, 2, 3. Our front view is all fully defined now. We're going to move over to our right view. Our first dimension that we're going to land in here is a dimension going between these two edges that make up this groove. So D on the keyboard, we're going to go from this vertical line to this other vertical line and drag our mouse up. Right click, press OK to get out of dimension mode. And we do have 6 different features that are sharing this measurement. So we're going to double click on this, put our cursor in front of that bracket and press 6x, or type in 6x, and then hit close, indicating that there are 6 features that share that measurement. The other thing that we're going to add while we're here is we're going to add our chamfers. This time we're going to use a text with the leader line. We're going to click on that angled edge there, drag our mouse up, and we're going to type in chamfer 10 thousandths by 45, and we are going to insert the degree symbol here and type in TYP, indicating that all those edges need to be chamfered at 10 thousandths. I'm going to hit a little return here. That way we can stack up our text box. Now that our right view is fully defined, we're going to move over to our detailed view. We're going to go D on the keyboard for dimension. This time we're going to click on this radius at the bottom, and we're going to drag our mouse up and over like so. We're going to right click and press OK, and just like before, we're going to click on this, and this time we're going to type in TYP, indicating that at the bottom of each one of those grooves, it's going to have an 8 thousandths radius to it. While we're here, we're going to further clarify that the chamfer here is the same chamfer that we typed in here. So again, we're going to use a text with the leader. We're going to come off of this angled edge, chamfer 10 thousandths 45 degree TYP. Notice that our view is kind of going off the part here. So we can always click on our different views and drag them around and give ourselves a little bit more space. Like so. While I'm here, I'm going to move this text box up and get that a little bit closer to our part. Now we're going to move down to our bottom view. The very first thing that we are going to do on this bottom view is we're going to add in some construction geometry. That way we can reference off of this. We're going to go to geometry and down to center line. We're going to click on the outside portions of our lines that make up the outside of our part. Then right click and press OK. Next we're going to click on our construction line and grab the arrowhead, and we're going to move our mouse up and find an endpoint on the front of our part and drag our mouse over till those endpoints intersect, and that way it will terminate our construction line at the front of our part. Next thing we're going to do is go up to dimensions and down to ordinate dimensions. We're going to find that endpoint here, drag our mouse up, landing our datum location. Then we're going to zoom in and find an endpoint on the front of our part and drag our mouse over and find a datum or an enter R0 at that location. Next, we'll press OK. We need to change these dimensions the way that it's stated from 3 trailing zeros to just read 0. We do this by double left clicking on it and changing the primary precision in our pop-up window to read 0. We'll repeat that on the other 0 location. Now that we have our dimensions in, or our zeros in, now we're going to start adding in our dimensions. We're going to go to ordinate dimension, and we're going to pick off this endpoint of this arc here. This will indicate the horizontal measurement for our groove here. And I'm referencing off of the previous extension line that I created. And I'm going to land my new dimension at that location. I'm going to repeat this on the outside of our part. And again, referencing off the previous extension line. Now that we have our horizontal measurements in place, we're going to do the same thing. But to prevent our workspace from getting really cluttered up, we don't need to measure or state all the measurements of each one of these points coming off of these webs here, because we've already defined it up here with that 6x 60 thousandths groove width. So what we're going to do is we're going to measure off of the back side of the groove. So we're going to measure off of this edge here, come up to our previous extension line, and drag our mouse down. And we're going to repeat that on every single one of these grooves, again measuring off of the back side of the groove. Now we could add in all those measurements here, but that will really clutter up our workspace. It'll make it a little bit harder to read and understand what's going on this print. Now that I've got the back side of the grooves landed, I'm going to measure off the bottom of the part. Again, referencing off of that previous extension line. And that gives us an overall length of our part. I'm going to right click and press OK. We're going to add some clarifying measurements here. We're going to go D on the keyboard. And this time, what we're going to be measuring is the diameter between the groove here. So we're going to click on one side of the line that makes up the groove, and then the other line that makes up the other side, and then left click again. And that gives us our width across there. The next thing that we're going to measure is the hole diameter here. Same thing, we're going to go from line to line, like so. And then the hole diameter down here. Lastly, we're going to measure the outside of our part, going from the external lines. I'm going to move these dimensions on the outside of the part. So we're going to right click and press OK. We're going to click on each dimension, and this time we're going to drag an extension line out to the outside of our part. And we'll do that for each one of our dimensions. This measurement of 314, this one needs to go all the way through the part. We're going to double click on it. First thing that we're going to do is we're going to click in front of the bracket here and insert a diameter symbol. And then this one needs to go through, so we're going to put a little note there indicating it goes through the part. These other measurements here are going to need some diameter symbols on it, so we're going to insert those now. This 426 up here, not only are we going to insert the diameter symbol, but we're also going to put the depth of this hole, so by 500 thousandths, and then we're going to insert the GD&T symbol for depth. We're going to hit Shift Enter, and we want this one to have a 140 degree drill point on it. So when you drill this hole, they want you to use a drill bit, most likely a carbide drill bit, with that 140 degree included angle. This 830 thousandths, we're going to add in a diameter symbol to it, and then close that out. And then we're going to realign some of these measurements. That way we can get the extension lines kind of all in alignment here. Like so. Now some of you are probably noticing that these measurements don't correspond to the Titans of CNC measurements. And what's happening is when we entered the threads on these holes and we applied these threads in Fusion 360, what they're doing is they're actually looking at the machinist handbook tables, and this would be actually one of the minor diameters of the hole when you actually drill it before you apply your threads and tap that hole for threads. Same thing with this number down here. Now, if a customer is stating that they want this to be 313 thousandths, or this one to be at 423, you can actually double click on here and you can delete this value here and type in a value manually in here. But we're going to leave these alone for right now. Next thing that we're going to do is we're going to call out these threads. I'm going to use a text with a leader. And we're going to point to this edge right here. Drag that line out. These are half 13 unified course. And these are going to be class 2B threads. We want these threads to go down 320 thousandths minimum for their depth. And then we'll close that out. We're going to repeat this down here for these threads on the other side. Again, putting in a text with the leader line. These ones here are 3/8 16 unified course, class 2B, 320 thousandths minimum, and then the depth symbol. And then we can close that out. We can move these text boxes around to help kind of further align things as you see fit. like so. Almost done with this print. Last thing that we're going to do is update our title block. What we're going to do is we're going to come over and double left click on our title block where we have our lines. We're going to go in to our attributes here where it says material, and we're going to type in 6061 T6 AL, and then we're going to go over to our revision block and go to revision A and press OK. Other than that, this concludes our tutorial on how to create a drawing for the Titan 87L.